This lesson is on the remaining triangle congruence theorems and postulates. Angle side angle says that if two angles in an included side of a triangle are congruent to two angles in an included side of another triangle, the triangles are congruent. So let me draw you a quick picture. If we have a triangle here, and we have a triangle here, so we would say this would be congruent to this. Then we would have this angle is congruent to this angle. And here's your included side. It's the side in between these two angles that we're looking at. Then you can call these two triangles congruent by the ASA. So if we look at an example here, then once we were able to do that, we're able to conclude some things like B is congruent to E, A is congruent to D, C is congruent to F. We can have these sides here are congruent. But your first objective would be to prove that the triangles are congruent. So notice we have angle, side, angle is congruent to angle, side, angle here. So when you are able to say that, then you can say your two triangles are congruent. Another one is that if we said if two angles in the non-included side of a triangle are congruent to two angles in the corresponding non-included side of the triangle, then the two triangles are congruent. So again, let me draw you two pictures. Sorry, these pictures are so bad. Okay, so we would have like an angle and an angle be congruent, an angle and an angle be congruent, and then we would have like a side here. So it would go around like angle, angle, side. And so when you have that, you're able to say these two triangles are congruent. So if you look at our example here, we see just that. We have an angle, we have an angle, we have a side. So this could be angle, angle, side. If the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of the other, then the two triangles are congruent. So we got a right triangle. I'm going to say this hypotenuse is congruent to this hypotenuse, and then one of the legs is congruent to the other leg. Well, it makes sense, because if we use the Pythagorean theorem to find the third side, these two sides would be congruent, because if these measures are the same, then obviously the final leg would be the same. So these two triangles are then congruent. So you see in our example here, we have a right triangle, and then we've got the hypotenuse and one of the legs are congruent, so we can say the two triangles are congruent. So in this example, it says determine whether there's enough information to prove that the triangles are congruent. To make this a little easier for you to see, I have an angle and an angle, I have a side and a side, and I have an angle and an angle. So you have to look and say, alright, is this side, angle, side? Well, side, angle, side requires two sides. I don't have that. I've got two angles. So the two angles ones we learned today were ASA and AAS. So that means that, I didn't mark this well, that means that this side has to be between these two angles for it to be ASA. But it also means that if we're going to do AAS, it's got to be angle, angle, and then a side. And so yes, this one does need AAS. And then if we look at this one here, we've got a side here and a side here, or an angle and angle. Here's an angle and an angle. And then this side right here. So we've got an angle, side, angle. So this one does fit angle, side, angle. So yes, these two triangles would be congruent. If we look at this one here, all we've got is that this side and this side are congruent, this side and this side are congruent. What we don't know is whether these are right angles or not, because they're not marked. So we can't say hypotenuse leg here, so there's not enough information. And then finally, we get into proofs. If you'll notice here, it says that AB is congruent to BD. So we're going to start with that. AB is congruent to BD. So we'll mark these right here. We have that BC is perpendicular to AD. Now, if they're perpendicular, then what that means is that we have two right angles. So we're going to start with our given. I should have said that was given before. So we have BC, segment BC is perpendicular to segment AD. And that also is given. And then we can say angle ACB and angle BCD are right angles. And that's because perpendicular lines form four right angles. And then we can say that angle ACB is congruent to angle BCD because of the right angles congruence theorem. State that all right angles are congruent. And if we can say these two are congruent, we can find our last side here, which would be BC is congruent to BC. And so, on number 5, we can say the reflexive property. And finally, if you look, we've got a side, and an angle. Actually, that is not a theorem here. So hold on just a second. I'm going to look at this to make sure that there isn't something else that I've missed, because we actually can't prove that these two triangles are congruent without more information. So give me just a minute. Well, we have a hypotenuse leg. So I didn't even pay attention. There's the right triangle. So we can say that these two triangles, ABC, is congruent to triangle DBC because we have the hypotenuse leg theorem, which states that if you've got a right triangle and you've got both the hypotenuse and a leg that are congruent, then the two triangles are congruent.